OPSIS products are internationally approved, for instance by the TÜV in Germany, MCERTS UK and US EPA. And OPSIS also have the ISO certifications for environment and quality, and in addition to that, we are also an accredited laboratory. So what do we do? Well, we make monitoring systems based on DOAS technique. And what is DOAS? It's differential optical absorption spectroscopy. Basically, we send a light beam across the air or across a stack, and then we can monitor the differential absorption of various gas compounds. We use this? Well, first we started to use this technique for air quality monitoring. Different kind of applications, such as monitoring the air pollution from traffic in cities, along streets, and so on, but also at industries to monitor the fugitive emissions around industries, and in airports, and so on. So, about this technology, could we use it for monitoring stack emissions? Of course, we just have to send the light beam across the stack instead of a long path in the ambient air. So now we have equipment for monitoring the pollution from power plants, waste incineration plants, cement plants, steel plants, chemical industries, and so on and so on. Really, it doesn't matter what kind of plant or application it is. A gas molecule is a gas molecule. If it happens to be in a power plant or in a waste incinerator plant, our analyzer really doesn't care. Why do you use emission monitoring at all? Well, of course, you have environmental regulations, and they're getting more and more stringent year after year. We have a number of regulations in Europe, for instance, that we have to meet. And basically, all industries that have some kind of emission needs to have analyzers to monitor that they are below the approved emission limits. And in the stack you have a number of gas pollutants. Normally you would look at NOx, SO2, maybe CO, CO2, and so on. But with our system you can monitor hundreds of different gas pollutants. So when the new regulations are coming now or in the future, for instance for monitoring mercury, we can use the same analyzer just by a software upgrade, and we can add this capability to the system. And we have QA/QC kits with calibration device that we can monitor the response of a calibration gas, a standard gas, zero, span, multi-point calibrations and all that. But in the DOAS analyzer, a number of quality parameters are monitored in real time inside the analyzer and will give you an alarm at any time if there's anything wrong with the system. You can see some examples of installations here. This is the shelter, which contains the two analyzers here, the two yellow boxes. They are the UV and the IR DOAS analyzers. And the small box on the ducts outside is the actual receiver, where the light is then passed into the shelter and to the two analyzers, monitoring in this case NOx, SO2, CO, CO2 and water vapor. Here is a case also from Malaysia, from the national power company, Tenaga Nasional, where we're actually monitoring directly after the gas turbine. And it's very hot, it's 550 degrees C, the ducts are moving, it's a very difficult job. And then we can use the standard UV DOAS analyzer to monitor the mercury content. You can see some parts close up here. We have the measurement cell to the left. We also have sensors here for temperature, pressure, oxygen, flow measurements, and so on in this measurement path, so that we can get a complete and naturally corrected value according to the existing temperature and pressure in the flue gas. We have the probe, sample line, and all this together will become a complete measurement solution. Now, if you remember from the beginning, I told you the UV DOAS analyzer and the IR, we can monitor hundreds of pollutants, and so we can here as well. Actually, OPSIS is the only... You can calibrate the system very easily using closed cells. no need for calibration gas. We have simply a droplet of mercury in a cell. It will generate a known vapor pressure, so if you know the temperature, you can use it for calibration of the system. But if you want to also check the performance of the converter, then you of course need to calibrate the total mercury compounds, introducing, for instance, mercury chloride into the converter. And for that, we need a gas generator. We need that to generate that. Of course, to monitor all the other gas compounds, we cannot put them through the converter, as some compounds will actually change during the pass-through of the converter. So we just have a small switching valve, and we can bypass the converter when we monitor the normal gas compounds. And in this way, you have a complete solution for all gases. You can also do like this. That means if you already have a cross-stack in situ monitoring system for monitoring NOx, SO2, and so on, you don't need to buy a new analyzer for mercury. You just add the sampling system and the measurement cell, and the analyzer stays the same. It can monitor mercury with just a software upgrade. We have done significant tests for the mercury systems in Europe. It's been tested by the TÜV, and we have the TÜV and EMCERT's approvals, and the excellent results have given us a certified measurement range of 0 to 45 microgram per cubic meter. And of course that is perfect and specific what you would need in a coal-fired power plant, this measurement range. So the summary of the benefits of this system that we have today is that it's approved for monitoring total gaseous mercury with a range 0 to 45 micrograms. But it's also approved since a long time ago for other gases like NOx, SO2, CO, water, and other compounds, for instance HF, HCl for waste incineration plants and so on. It is a well-proven analyzer technology. Though we have been around for almost 25 years,